Okay, here we can use a u-substitution to find a formula for the antiderivative of tangent x. So if you look at our table, we don't know currently of any functions whose derivative is tangent of x. So we know how to differentiate tangent of x, but we don't know of a function whose derivative is tangent of x. So here's what we're going to do. We're going to write this thing as sine over cosine. So now this is really antiderivative sine x over cosine of x. And now I'm going to let u equal the cosine of x, because when I take the derivative of cosine, I will get sine. If you try to let u equal sine of x, you won't get a reduction. I mean, go ahead and try it. You'll see that things only get messier. So I'm going to let u equal cosine of x, and let me do this all in one step. So that means that du over negative sine of x is equal to dx. So now I can write this integral as antiderivative sine of x over u, and then what is dx? It's du over negative sine of x. And so now the signs will cancel. Don't forget to pick up the negative sign here. So this is negative the antiderivative 1 over u du. And we know what that is. That's negative natural log absolute value of u plus c. So now we just want to write this thing in terms of x now. So this is equal to negative natural log of cosine of x plus c. But now remember, the negative out front means that we can write the negative 1 power inside the parentheses. So this is the same thing as natural log cosine to the negative 1 power. That's not cosine inverse, it's the reciprocal of cosine. And so remember, the reciprocal of cosine is just secant, and so this thing is equal to, this antiderivative is natural log of secant plus c. Okay, here's one that might take a little trial and error. So you might be tempted to let u equal all of 1 plus e to the 2x, but if you think it through a little bit, the derivative of e to the 2x is 2 times e to the 2x, and you know, we're trying to get things to cancel. 2 times e to the 2x is not going to cancel entirely with e to the x, right? You're going to have like an e to the x left over, and so that didn't really reduce anything to begin with. So what I'm going to do is try to go in and make u so that it will cancel with this extra piece in the numerator. Well, the derivative of e to the x is e to the x. So it might be good to just let u equal e to the x and then recognize this thing as u squared. So here's how that's going to play out. So I'm going to let u equal e to the x, and so du over e to the x is equal to dx. So now, this thing, when I rewrite it, so now the antiderivative is u over 1 plus u squared, and then what is du? Or sorry, what is dx? It's du over e to the x, or du over u. And so now that's good. Now the u's cancel, and so I get that this thing is really the antiderivative 1 over 1 plus u squared du. This, of course, is tangent inverse. So tangent inverse of u plus c, and then when I substitute u back in, I get tangent inverse of e to the x. So that would be a good final answer for this thing. And you can check. take the derivative of this thing, and you will get this original thing back again. Okay, here's another very standard example. And in this case, we will need to make a bit further use of our original u-substitution. So we'll pretty much have to use it twice when we work this problem out. So, two functions, the derivative of 1 plus x is 1. It's not going to cancel with this thing. We really don't have any other choice but to try to let u equal 1 plus x. So let's just try it. A lot of times in u-substitution, trial and error is the way you have to go. So u is equal to 1 plus x. That means that du is equal to dx. And now when I make the substitution, I get x times u to the 1/2. And then du is just equal to dx. So here I get du. But the problem is, I can't have any x's left once I make the substitution. So we need to try to write this thing in terms of u. So go back to the original substitution. This thing says that x is equal to u minus 1. So just subtract 1 from both sides. Basically just solve for x, right? Just solve for x, and so I'm going to write it here. And so now this tells me that the new antiderivative now is u minus 1 times u to the 1/2 du. And so now you can just distribute the u to the 1/2. This is really equal to antiderivative u to the 3/2 minus u to the 1/2 du. And so we know how to anti-differentiate this thing. That's going to be u to the 5/2 over 5/2 minus u to the 3/2 over 3/2 plus c. And so now I want to write my answer in terms of x and maybe get rid of the fractions on the bottom. So now this thing is really equal to 2/5 and then x plus 1 to the 5/2 minus 2/3 and then x plus 1 to the 3/2 plus c. So this would be a good final answer for our original antiderivative. Okay, here's a similar situation where we're going to have to make extra use out of that original u-substitution. So if I let u equal x squared, the derivative is 2x. 2x is not going to cancel with the square root of a thing. So the only other option is to let u equal 1 minus x. So we'll start there. So u is equal to 1 minus x. That means that du is equal to negative dx. And so when I make the substitution here, I get I is equal to x squared in the numerator, and then u, let's go ahead and call it u to the negative 1/2 in the numerator. So x squared u to the negative 1/2 du, and actually I need to make that negative du. So again, we've got an extra x left over, so I need to try to write this thing in terms of u. So I'll go back and make further use out of my original u-substitution. This tells me that x is equal to 1 minus u. And so now this antiderivative, it's 1 minus u quantity squared times u to the negative 1/2. And let's go ahead and write the negative sign out front, times du. And so now I'm going to do what I did before. I'm going to FOIL this thing out, and then we'll multiply through by u to the negative 1/2. So this is negative 1 minus 2u plus u squared, and then u to the negative 1/2 du. That's the same thing as negative u to the negative 1/2, and then minus 2 to the 1/2, so minus 2u to the 1/2, and then plus u to the 3/2. So now it's just an easy matter to apply the power rule for antiderivatives to all three of these things, and then add c, and then make sure to replace u with 1 minus x. And there you can get a good final answer.